Hi, everybody, and welcome to another great episode of the Infrastructure's Code podcast. Today we have John Willis. That's a great honor. John, thanks for coming.
Hey, it's great to be here. So,
John, I'm sure most of our listeners already know about you, but if you can share a little bit more about your background, please.
yeah, I've been doing this stuff. I always could consider myself as an ops person, although I think we'll talk about what's the difference these days between dev and ops is not much, I think. But I started out classically as, literally working on mainframes doing IBM assembler code. That was my first job. I won't bore you with the first half of, my career, I guess 40 plus years. But I got real fortunate. I did a startup, and my business partner sold me out, and I was looking around. I was doing a lot of proprietary, pre-infrastructure as code. I mean, it was just configuration management, what we called it back then. And I was doing that for large banks with the IBM Tivoli portfolio. And my business partner bought me out, and I had like a 1 year non-compete, and I just started looking at all the open source solutions
Hmm.
to see what was out there, and that's why I wound up running into CF Engine, Puppet, some of the monitoring tools, and sort of just went all in on distributed, what we would call open source, the sort of I would say starting the sort of next generation of a lot of his
Yep.
technology. So
Yep.
yeah, and just rode the wave, because people tell you I was very early in. I was the old guy they hired at Chef, so Adam Jacob,
Yep. Yep.
looked great. I love Adam, and he sort of, the old guy went up to him and said, "Hey, you think you'd hire me?" And he's like fist bumps me, like, "Yeah," and so spent a little
Awesome.
while there running that, and then I've done a ton. I sold. I mean, probably my two biggest claims to fame for this audience. Well, my biggest claim to fame, my two boys, but the my biggest claim to
Yep.
fame is I sold a company to Docker. I did a startup, and that was
Mhm.
really pretty awesome. And then I'm co-author of DevOps Handbook, so that's
Yeah, definitely, definitely. Thanks. I want to mention you just mentioned Adam Jacobs, so he was another guest as well in one of the previous episodes, the creator of Chef. You also mentioned Ansible, not Ansible, excuse me.
CF Engine.
Huh? No, no, no,
CF
no,
Engine. Oh,
no. Assembly, writing
oh,
code
assembly language. Yeah, yeah, yeah,
in
yeah, yeah.
assembly, and honestly, I also had the honor of writing some code in assembly in the like 20 something years ago years
Yeah,
ago,
yeah.
and the documentation for assembly, not sure how you learned about assembly, but I actually got a book, like a very old book about assembly, because it was written before Google and search engines were created,
Yeah,
so
yeah,
I
totally.
actually used the book in order to properly use assembly. So
Well,
but as
when I started, all the source code, they didn't call
Mhm.
it open source, but all the source code for the IBM operating systems was on microfiche.
Mhm,
So,
mhm.
in fact, as a young sort of entry level programmer, the old timers would tell you, "Okay, I need you to put a patch. You need to turn this block size from 32K to a million." I worked for Exxon Geophysical Processing, and they wouldn't tell you anything. They're like, "Here's the microfiche. Go find the routine that has this." And you look and you somewhere find like a declarative statement for the block size, and you
Mhm.
cross your fingers and make a patch, and you turn it to like, and
Yep,
and
yep.
then doing that, I did that for 10 years basically. And I'll tell you
That's
this for
awesome.
anybody young, learning how to program assembly first. I'm sounding like one of those old guys that says, I used to walk miles, but the appreciation and understand the underlying um, primitives of all programming languages. I would never trade that for. I wouldn't say I'm a great programmer, but I can program in any language that's ever been thrown at me. Erlang,
Mhm.
Prolog,
Yeah,
assembly, Go, Python, because I started out as an assembly programmer.
cool, cool. So obviously you've seen a lot throughout the years, and let's jump all the way to cloud native and infrastructure as code. You've mentioned earlier that DevOps, Dev, and Ops, maybe it's practically the same today. Can you elaborate on why you're saying that?
Yeah, I mean, the interesting thing, right? And you've been doing this for a while too. So, I think there was this, we were just blinded by the fact that, and this sort of acceptance of, the crazy things that we were doing, which was we had a brick wall between developer and operations. And it's been like that as long as I can go back, even before
Can you give an
distributed.
example? Can you give an example
Well,
of
I
such
think
a
Andrew
model?
Clay Shafer used to have probably most people have seen this caricature of the wall of confusion, he called it, but he did it in one of the first earliest pre-DevOps presentations, called Agile Infrastructure. And the wall is this brick wall, and you have sort of a character with code on one side, and you have an operations on the right hand side of it. And the character on the left is throwing the code over the wall, and the character on the right is trying to catch it, right? And then if he catches it, it doesn't know what to do it. He or she doesn't know what to do it. They sort of turn it on, and there's no documentation. It doesn't work right, and they yell back over the wall, "Hey, your code doesn't work," and they're like, "Yes, it does. It worked on this side of the wall," and
Yeah,
and like
yeah.
that was the way, like,
It
we just,
works. It works on my machine.
yeah, yeah. This was like on my side of the wall, but yeah, I mean, I had that just the other day with a vendor where the guy's like on an AI thing. He's like, "It works here." I'm like, "Oh, we're still saying that in 2024."
Yep, yeah,
But
yeah.
and I think that there was this, for me, it was Andrew Clay Shafer who he was on a podcast and he was talking about agile infrastructure, and I called him. I'm like, "What is this agile?" Because I'm an infrastructure person. I knew agile, but I wasn't really back then. You were sort of separated. you know, Back then you really didn't code. I mean, like you coded Bash basically. Or I did a lot of Perl. I was a Perl ninja back in the day, right? But
Hmm.
you didn't
Hmm.
really code Java. Or you didn't code it. You didn't really coded anything with object-oriented languages or anything post that. And I called him. I'm like, "What is this?" And he's like, "There's this guy in Europe that's running this thing, or and it was Patrick, and I tracked Patrick down, and I was at
Patrick
Canonical.
Dubois.
Yeah, Patrick
Mhm.
DeBar, the Godfather, and I was at Canonical working for Simon Wardley on their first cloud product, and I called Patrick, and Patrick said, "You know what? If you can get Canonical, because they didn't have anybody from the U.S. even knowing about it. They were going to run the first DevOps days in Ghent." And Patrick said, "Well, if you can get Canonical pay your travel, we'll give them a sponsor logo." So I
Mhm.
showed up the first DevOps days in Ghent. I was the only American there, and like, "Oh my God, this is unbelievable what's going on here!" Like the stuff that I was seeing, and even then I was older than most people in the room, and I was
Mhm.
like, and then I went back to Damon Edwards and I told him, we got to do this. We got to do this in the U.S. And we ran the first DevOps days at LinkedIn, in 2010, basically. The first Silicon
Mhm.
Valley. But yeah, but that whole idea of that, I mean, Andrew to me is really, sort of set a lot of things in motion, and that idea. So fast forward, my long-winded answer was, once we smashed that wall, the idea was, let's break down that wall. Break down that wall. Let's
Mhm.
collaborate. Let's get developers thinking about operations. Let's get operations more in tune with what developers do. Take on more
Mhm.
responsibility for coding. And so today, I work with some vendors that still think, that everything's, get a billion developers, get your code, and then you'll get rich. And I'm like, the people that actually control the budget, I'm sure you guys
Mhm.
know this, are the infrastructure and operations people, you know,
Yep.
and if you want to get an enterprise license with a large bank, or you're going to have to win there. So, and they're not rack and stack anymore. And I know that's weird to say for our crowd, but like there's still people who believe that, oh, operations, why would they care about code? Like some of the hardest interview processes you can go on today are not a Java position in a bank. It's
Mhm.
the DevOps team. You,
Yep.
you have to know Kafka. You've got to know distributed computing. You've got to know at least two or three languages, right? Like I would say in a lot of companies, other than the Googles and the Facebooks, but if you're going to a bank, it's probably a tougher interview to get into an infrastructure and operations or an SRE, certainly an SRE or a DevOps position, than it is probably to get into an app dev position from a technical interview process.
You're saying that the challenge in the big enterprises, in the big financial institutes, is how to manage the infrastructure and the different skills that you need to know in order to actually do your job properly. It's and you mentioned knowing programming languages. Uh, Maybe nowadays it's even more than knowing; it's actually coding
Yeah.
in those programming languages. You just don't just need to review those. You're the actual person who writes, whether it's CloudFormation or Pulumi or other language, and obviously still using some configuration management, whether it's Chef or the more common Ansible. So if they become developers, is there still a wall between dev and ops?
Yeah, no, I think that I think that, if to the extent that DevOps has been successful, and I would say it certainly has, but it's not universal. There are still companies that still think operators are rack stack, but in the world that mostly we live, DevOps has made a difference, and in that world there is no wall. We succeeded in crashing that wall. That developers, and you're right. I wasn't trying to imply that they just know how to code. These are people that can code, that are
Mhm.
that because not only are they responsible for automating the infrastructure that supports all that code, right? And that's, I got some bias here, but that's the hard stuff, right? Making it all connect, right, with all
Mhm.
the relational databases, the non-SQL databases, the event buses, the event, all everything, that's, I mean, I'm always, I'm a consultant. I'm a writer. I dabble in some work periodically, but I'm always amazed that somebody who works for like a J.P. Morgan Chase and is right in the middle of having to deal with all this emerging tech on the infrastructure side. That's just a daunting position to keep up, and to watch some of these people show up at a conference and talk to them, and like, yeah, yeah, they know the depth they know. So, and then SRE has, as we know, has really raised the bar, right? Because in SRE, not only do you not need to know how to code, you got to have a really good understanding of how the coders who code on the other side of what used to be the wall code, so you
Yep.
can better
Yep.
support them, and you got to know everything
Yep.
else. You got to know as much as the Java developer or whatever the application language developer is for the business. You have to equal their talents, but then you have to know all the glue that makes it work, right? So yeah, no, it's there. I would argue that, and I know this isn't universal because there are different stages of people's DevOps journey, or what we would call a sort of distributed technology today. But in general, the wall has been gone for a while.
So let's maybe talk about another potential wall, which is the wall between the developers and the production environments. So now you have all of those developers on one side. Some of them are in charge of the infrastructure, some of them are in charge of the application code, but all in all of them have access to change code. And then they throw all of that into the deploy to the production environment. Do you think the risk, to what it means or the implications on what it means to change code and the blast radius um, change in a way that is more risky, in a way of what developers can do to harm the production environments, their stability, their security, cost. You can easily change a line of code that will provision expensive cloud resources. So maybe now the wall is not between humans, it's between the cloud account and all other humans. So how are we facing this new challenge, and how do we govern, let's say, infrastructure as code at scale?
Yeah. No, I think, if you think about, like, I think, like Docker changed everything, right? In that there, so I said that the wall's been gone for a while, but there still was sort of a fence, if you will, maybe not a wall, which
Mhm.
was developers could only go so far prior to Docker in general, right? Again, these are all generalizations. Like, somebody could be scouting right now. I got a use case for that's not, no. Okay, good. But in general, developers basically had a fence that they ran into, right? Which was they could get their code reasonably far, but it had to be staged somewhere or committed to somewhere that a process took over. And the delta between what they tested and coded, which usually was their laptop or some dedicated, test environment, and how it got to its final stage, there was a pretty decent level of variation there,
Yep.
right? And so one of the things that Docker did, in fact, I remember, speaking of infrastructure code, Stephen Nelson Smith wrote a book, Test-Driven Development with Chef, way back in the day, before even Docker was even a sort of a term. And in it, like in the later chapter, he talked about like how we could use containers on Amazon's cloud and do like incredible parallel testing.
Hmm.
And I always consider myself a horse, not a unicorn. And I spent 3 or 4 nights trying to get it work on Amazon, where I had to create my own kernel. And I'm like, you know what, life's too short. I gave up.
Hmm.
And then I met Solomon about 6 or 8 months, a year later, and he gave me early access to the private repo that became Docker, and I had a container
Nice.
up in like 3 minutes. And I like, this is going to change everything. So to your point, it got developers much further with less variation. In other words, if they could containerize the services they were working with in a test environment, encapsulate those in containers, those images then run in production, it wasn't complete non-variation, but
Yep.
the extent of, and I always said that, like, if something went wrong, operations had a clearer view of what it could be, the infrastructure or the app, because of that isolation in a container. But what happened really fast was we started using it at scale. And now all of a sudden we got this new problem, which is it's just not 10 containers running on a server. It's containers starting, stopping, and if you look at where the history comes there, right, this is what Google did, right? Google's, by the time we're all just scratching our head learning about containers, they've been running, a billion containers up and down a week, right?
Yep.
And they solved this problem, 10 years before we did, right? Which
Hmm.
was they wrote a platform infrastructure, right? That we know
Yep.
as the open source Kubernetes.
Kubernetes.
But
Yep.
now, but that gave us, so like there was this, sort of like, oh great, okay, we all we got to do is now we've taken this simple, and to my point, containers were like beautifully simple, right?
Yep.
Like my point was when I tried to create a container before Docker, I gave up. When Solomon gave me access to the repo in 3 minutes, I had a container running, and that's not because I'm smart or anything. It was just because it was simple, and developers were able to do far more extensive things. But then also you put in the platform, oh, another simple thing. This is going to be great. And guess what? It wasn't simple. The whole construct of how Kubernetes works by design was
Hmm.
complex,
Yep.
right? Like, and nobody even understood it was like a massive event loop, and there were, you had to build, you had to do some like heavy some for most horses, the idea of creating an operator was not a simple task, and so I think we live in that world now, and I think the interesting thing, if I look at the history, was when Docker came out, a lot of the infrastructure as code companies, including my dear friend Adam and Puppet, they tried to ignore it and they tried to act like, you don't need to do this. Their first stage of denial was, you don't need that. The second stage of denial, Adam's gonna get mad at me. Second stage of denial is, we'll go ahead and create Docker files with infrastructure as code. I'm like, come on, guys, get with the program, And then finally, everybody was on board, and then and I love how Chef found their way, right? Like, I think Habitat was a great product, misunderstood, but that was a good example of them taking all that expertise of how to manage what you're saying is the sort of this new problem at scale.
Hmm.
And so today
Yep.
we live in, a world that I think, I think Pulumi's, I don't dabble as much in infrastructure as code. I can run, um, I love this open tofu stuff. This is really cool. But
Thank you.
I'll say Terraform and Ansible, and I like how we've simplified infrastructure code. I mean, because to be blunt, when I left Chef, like I had a pretty good grasp what Chef was doing, right, and how to do just about anything I could do. A year later, a year and a half later, I'm coming back, and they had made it way too
Hmm.
complicated. And I think that I always joke that the sort of the worst collision in DevOps history is putting Luke Knies and Mike DeHaan in the same company. Because what do you
Hmm.
get? Ansible, right? So, but it was a simplistic. It was like it's what most people needed was the
Yep.
simplicity.
Yep.
And I think there's a beautiful marriage now between sort of where infrastructure code is today, like the Pulumis, the Open Tofus, and the balance of containers. And I still think the platforms. I know we talk about next week is going to be 8 million people running around like lambs to the slaughter at KubeCon, but
Hmm. Hmm.
I'm a little cynical. It's just far more complex than it needs to be.
Hmm.
Simplicity, we go through these phases of like complexity and simplicity and complexity and simplicity, and we don't sort of learn that the simplicity is the answer. I don't know. What are
Yep.
your thoughts about all this, my rambling?
Definitely, Docker changed the variation, between
Yeah.
what's running on my hardware, on my infrastructure versus what's eventually gonna run. I remember the first time that I saw GKE and wondering when Amazon and Azure are gonna do similar things. So yeah, I think general how compute became
Mhm.
more in a way standard with those concept of Docker, and then Kubernetes dramatically reduces the friction points of what happens when I develop something versus what happens later when it's
Right.
in production in my Kubernetes cluster. But I think in general, infrastructure is much wider than just Kubernetes and compute. You have databases, you have serverless, and even
Right.
within Kubernetes, those things are complicated as you mentioned. So I see very often the with often CD and a lot of deployments happening to production on a daily basis. I see the increased risk of how easily now every developer can influence the actual architecture, the actual production environment, and that for enterprises causes a big risk. And I think the answer will be either in a commercial solution. A small disclaimer: M0 is definitely a position to help there, or open source projects, or just different type of concepts, as you mentioned, maybe simplified IaC that will have those built-in guardrails or something like that to prevent uh, disasters happening in production. So I think time will tell how this problem is solved in scale when every developer can influence and modify
Yeah.
the production
Yeah, it's
environment.
much harder. I mean, that was the downside of the simplicity of, gave the developers far deeper reach into production than they had ever had before. The positive was it became a revolution. The negative,
Yep.
like you say, there's a term that I'm doing a lot of thinking about infrastructure when it comes to the new generative AI stuff, right? And there's a term like change anything. Um, Changing anything changes everything.
Hmm.
And it's actually from a Google paper back 10 years ago when they were running into like very complex ML ops. So
Yep.
Google's always finds these problems 10 years before we do, right? So,
Hmm.
but I mean, I think that's the downside of giving more control to developers into production is, the non-deterministic nature of those changes can get very complex.
And what I sometimes say from Spider-Man, you gave a more serious quote, so I'll give a silly quote. With great power comes
Yeah.
great
Because,
responsibility.
uh,
So that's that's the life of today's developers. Uh, Listen, John, we are about to run out of time, and the little bird told me that you wrote a new book. Would you like to say a few words
yeah.
about your new book?
Yeah, so I for about 10 years I was obsessed with this management philosopher, management guru. His name is Dr. Deming. Most people, it's a lot of people in DevOps probably hears him because heard about him because there's usually a DevOps deck that has at least one slide talking about his 14 points or something. But I really wanted to investigate like who this guy was, what was the importance of his messaging, and his messaging is really sort of it. Even though he was born in 1900, died in 1993, sort of missed the whole everything exciting that happened from the late 90s on. Um, but he had these fundamental principles about, about cognition and systems thinking and epistemology, and he tied them all together in something called system of profound knowledge. And the short time we have here, I won't go into detail, But like any of us, we're systems thinker or think about complexity or do the kind of work we do. When you read the way he thought about this stuff 40 and 50 years ago, it's so relevant to the problems we have, which is like it's universal, right? It's relevant to the way you build cars, it's the way you build toasters, the way you build nuclear power plants, and the way you ship Java code, right? The primitives are the same. And just got obsessed about how relevant everything he said is to what we do today. So I worked on this book for like 10 years. I finally had it's published. It's called Deming's Journey to Profound Knowledge. You can find it. It's an IT Revolution book. So the same books that publish, all those great books by Gene Kim and the crew. But I really wanted to sort of go in and understand like what was the history of how he learned. Where did he get the system thinking, or where did he the like epistemology, fancy way of really saying scientific method, hypothesis thinking, making sure that we sort of follow through to understand the changes we made and the impact and feedback loops and all that stuff. So anyway, it came out in January. Pretty proud, and it probably the most interesting part for people like, why would I want to know? In the last third of the book, I do a what would Deming do, and I really focus on one of the short things about Deming is well known for is after World War II, General MacArthur, in a set of like pats, wound up getting Deming over there, and in a lot of ways, Deming was considered the sort of the motivator for the miracle in Japan. So all the Toyotas and the Toyota production system, which becomes lean, which becomes agile. A lot of people credit a lot of Deming's work for going over there as a sort of early American to help rebuild Japan. I wanted to do like what would Deming do if he was dealing with like the cyber crisis, and so the last third of the book I use a lot of what he did in the past with automotive and innovation in the sort of 80s and 90s. What would he do? And so it's a really fascinating book to look at, sort of the DevOps spectrum, the cybersecurity spectrum, and apply his principles. And so far, it's been received really well. So it's John Willis. Obviously, it's pretty easy to find me. Deming's Journey to Profound Knowledge. I'm getting a lot of great feedback on it so far. So
Congrats, this is amazing. Thanks for sharing.
sure,
And with that, I guess we're going to end our session for today. John, thank you so much for being our guest for today. It's been an honor talking with you about the past, the present, and the future.
the future.
Thank you so much,
All right, thank you.
and have a great day, everybody. Stay tuned. Bye bye.